Ladies and gentlemen, tonight...
You're on the wrong computer.
Ah, come on.
Number 3.
Number 3.
Number 3. Number 3. No, now it's good.
Start over.
Restart. You saw nothing.
Start music.
Excellent.
It's complicated.
Excellent. Ladies and gentlemen, today we're gonna see an epic face-off of voice UI between Google Home and Amazon Alexa. So, my name is Alex Shalaev, and I come from a company called Zero Turnaround. Our speakers asked me to moderate this battle, and I'm gonna do that. So you can find me on social networks because they didn't just give me a slide. With all that excellent and very important information out of the way, let's... Does this work?
Should work.
One big button.
Yeah, technical challenges already. Doesn't work.
Because you are not in the not in focus. Now it will work. The button.
Click. Yeah.
So the face-off. I'm not sure if you've seen those face-off or battles before, but it will work this way. We have two technologies, Google Home and Amazon Alexa. We're gonna have people present the cases for going this technology, why they're amazing, why do they think this particular technology should win. You guys are gonna vote. We're gonna use some mechanism like clapping or something, voicing, to decide what's best. And we're gonna vote for the winner at the very end. Without further ado, let's welcome our participants. In the left chair, we're gonna have Baruch Black Hat Blackbeard Sadogursky.
Now the music should come, but that's okay. We'll do it for Viktor. He's more important.
Excellent. In the right chair, we're gonna have Viktor Red Pants Gamov from Confluent.
No, it doesn't work. It's locked.
It doesn't work.
Because it's iPhone. It's so secure.
Yeah, it's so secure. Okay.
And it was Alex Shalaev.
Alex.
So, guys, introduce yourself and tell a couple of words. Why should we believe you?
Okay, so as Oleg mentioned, my name is Baruch. I'm developer advocate with JFrog. You can find me at JBaruch on Twitter. I'm a very interesting guy, so you should definitely follow me. Effort worthwhile. And I'm going to present Google Home today, and you will see how much it's better than the other alternatives.
Yeah, in this case, there should be ladies. That brings this like a Google Home.
No.
No? All right.
No.
All right. So there would be no ladies, but there would be here. He's gonna be a champion because he already won previous battles. I'm a contestant and contender. And my name is Viktor. I'm also an interesting person. You need to follow me. Today I'm going to be working with the Amazon. See, I brought 2 devices, so maybe with 2 devices I will be lucky today. So I will bring the heavy guns. I guess we will see who will win during this presentation.
Let's see if you know how to vote. Let's clap all together for the start. Yay!
Yay!
Amazing.
They got the idea.
Perfect.
Use this like a Java typical test that we're using. Who using Java 6?
Java 6. Now you should clap.
Okay. Who used just Java 7? Who used Java 8? Yay!
Hey.
Okay. Java 9?
Java 9?
Java 9? Okay, so
here is a couple of them. But you got the idea, right? This is how you vote.
Yeah.
Okay.
The louder you clap, the more you win.
Sorry,
This
that
is
was
important.
important. That was important. Sorry.
Terrible. So, additional information about how it's going to work.
Yeah, before that, we prepared a special page for you called the show notes. It's on jeffrog.com/show notes. You will find a page dedicated to this talk, in which you will find the slides. They're there already. The video, probably sooner than tomorrow. It's all on YouTube, so I will link it there.
I guess they stream it right now. So.
Yes, but not there. Source code of the code that you will see, very important. A bunch of links of how to get started and all the resources that we will mention and not mention today. And a raffle, which will be Amazon Echo Dot.
What?
Yeah.
Are you kidding me?
Yes.
So this is why you need to go
for being here and not in other awesome talks, basically.
Hello, YouTube live stream.
Okay, yeah,
Hey,
now
Mom.
you know.
Hey, Mom.
Anyway, so what are you going to see today? You're going to see a lot of amazing things. We're going to do a very simple example of a simple action or a skill, depending on the terminology, which device you cheer for. This is the simplest thing that you can ask from the voiced UI. We're going to see a more complex example called pagination. This is when the device will ask you follow-up questions. So you have like a chain of questions, maybe asking for parameters. We're going to see a proper conversation with this mechanical friend that you got. And this is what you're going to see. What you're not going to see is what you see in this picture, which is a lot of home automation stuff. That is sad.
That's not because we don't want to show this stuff, but because there is zero coding in it. It just works out of the box, or in this example of my thing, out of many boxes.
Yeah, so modern home automation is pretty straightforward. Like do-it-yourself things are pretty awesome. So this is why the Baruch started doing this thing, and after that the thing became contagious. I also have a similar picture of my boxes. So
it's not about coding, it's about a lot of tools, so it's not a particular focus of this talk.
Excellent.
And this conference, obviously.
We want to see the code, we want to see the hardcore action, we're going to see those things in...
Right, so let's talk a little bit about how it works, and it actually works the same for all of the platforms. No, we need Oleg for one more slide.
Absolutely.
So it all starts with user providing some input and actually saying something, starting with the words. Let me mute those guys for a second. Alexa or OK Google, and then the Alexa or Google in their cloud translate this speech to a text, right? What people actually said. Then Alexa and Google call your URL.
Or in my case, code.
It will be eventually. It goes to a service that can be invoked directly or through an API, right? And you implement the business logic. So you will see how we do that, and it could be calling third-party resources or do some kind of calculation, database access, whatever makes sense for us. Return the results to this caller, which in our case will be Alexa or Google Cloud, and then they kind of do their thing, show the UI in on the screen, if there is a screen. It will be Google Assistant
or Echo
or Alexa app.
Alexa app, or there's a new thing with.
So they show
Echo,
something on a screen.
Yep.
And of course, synthesize the speech. So we won't touch the screen part today because it's told you to turn it off. We won't touch the screen part today because it's kind of, we know how to.
Connected to Bluetooth.
It was automatically turned off, so.
Continue.
Please continue.
Okay.
Please continue.
And synthesizes the text in case of speech, which is exactly our use case. A couple of concepts that we are going to mention today, both of us, so you will know what we are talking about. Intent. Intent is the unit of action that is performed. When I ask a question, my assistant, I perform some intent, and then it goes to the backend and it returns. All the flow that I showed you previously is an intent. Sample utterances are the sample phrases by which Google and Amazon know what actually should be processed. And they're called sample because the artificial intelligence on those two platforms actually understand much more than what we provide as samples. So my sample could be yes, and then tons of synonyms for yes will be automatically processed for this request together with the simple yes that I provided in sample.
And other things. Yep. So today is also working.
Right. So of course, the more sample I give, the more real utterances will be recognized. So that's another thing that we will show you. Fulfillment is just a fancy name for our backend, the code that runs as a result of this trigger from Amazon or Google. And SSML stands for
Structured Speech Markup Language.
Thank you very much. That was a point, right? Which is a markup language for those machines to know how to speak correctly. So, for example, acronyms, should we read them as REST or REST?
Yep.
stuff like poses, stuff like ordinals, etc., etc.
And other things.
We will show a little example of SSML during our.
So how about like we stop talking and let them speak by themselves?
I think someone has to present what we are going to do.
Excellent,
Please
excellent.
do.
Let's be very quick about this. You all know the concept of the daily stand-up.
Who knows this? Who been on the daily stand-up? Anyone?
Everyone is super agile,
they keep working.
right? So
Good.
you do that. So how about we produce a little helper for the stand-ups? It will report our project status. It's gonna integrate with Jira, because why not? It's gonna list the bugs that are on a particular person's name. It has to have an easy way to mark bugs or other tasks as critical, as blockers, because that's what you do on a stand-up, right? And besides coming up with his excuses. So this
that
is what
will
we're
be
gonna
our
do.
example. Yep.
And now we're gonna start in a second. In the spirit of a true ramble, let's say Baruch his heads and.
Oh my God! You are
Viktor's
doing
tail.
that. Okay.
Okay.
That was terrible, but let's see. That's his heads.
So Baruch.
So Baruch and Google Home.
Of course, and this is my screen, so you might think that it was scripted that I start, but okay. I don't know. Okay.
You wanna unmute it? You wanna?
The mic's back on.
The mic is back on.
Okay.
Okay, Google. How are you?
I'm feeling helpful. What can I do for you?
Stop. Okay, so let's start with kind of the basics. How do you even start implementing your own, let me enlarge that a little bit. How do you even start implementing your own action on Google? So for that you have a page which is conveniently called Action on Google. And here you can, first of all, create your new project, but also see a lot of useful documentation, etc. So for Action on Google, you have two options of implementing an action. First, you can work with Google APIs, which is kind of a low-level bolts and nuts that you can deal with, or you can use something that is called Dataflow. Dataflow had last week a much better name. It was called API
Dialogflow.
And Dialogflow. And we will keep using the III name because it's so cool. I will call it III. But yeah, Dialogflow is a startup, or API. It's a startup that Google bought some time ago for this purpose, for implementing interactions with Google Home. And I would definitely recommend you going that way. And what it means to implement an action on Google in its simplest way. Default welcome event is what will happen when I ask Google to invoke some action. It has a special type Google Assistant welcome, and it has a bunch of welcomes, right? Google Home and everybody. Okay, so I want you to take a look on this one, for example, real quick. Here you go. Google Home is here. Hi, everybody. And
just make
Alexa, hello. I just wanted to show the SSML. So what you see here, this speak tag, is actually this SSML in action. And I have this special tag, which is break and given time of 1 second, and it will pause for 1 second for Alexa to proceed. Okay, so this is how it's implemented, and let's see if I can do that. Okay.
Make her talk. People came here for
it's up.
Her.
Okay, Google. Speak to stand-up helper.
All right, here's the test version of Stand Up Helper.
Well, let's see if this demo works. Praying to the demo gods. Echo fails, Google works.
Now, this is all. You have your own action implemented on Google, right? Of course, we will get...
Oh, no. Defect all, you have your own action implemented on Google is a catastrophic...
Oh my God, no, it won't help.
The
Stop.
mic is muted.
You continue. You can continue. And after that, you can return.
The mic's back on.
Stop. Stop. Okay, I guess she stopped. Okay, so this is like the bare minimum. You return a phrase. And of course, we will get to more complicated stuff later.
All right. Now when you see my screen, so in Amazon, you're starting with something similar. So let me do this.
The mic is muted.
All right. Now talking to this guy. Alexa, start stand-up helper.
Hello, Devoxx people. I am your humble stand-up helper.
So basically, pretty much the same thing that Baruch just demonstrated with Google. You can do it with Amazon Cloud, Amazon Web Services console. They have this in the developer portal. There is Alexa a place, and I can create new skill. So,
oh, Captain, my Captain. Waiting for your command.
Stop.
So she was waiting for command because when I start programming this thing, there's have like more sophisticated thing. She introduced herself, and after that she was waiting for command. So she was starting a dialogue from the very beginning. So now she was waiting for command, and she's replying that she's waiting. Now, so on this console, I can create new skill, and in this particular case, I already have this skill. It's called stand-up helper. So we have both stand-up helpers in this case, and this is how the console from perspective of development looks like. So as a result of calling this skill will interact with Amazon Lambda service, which in my case implemented in Java, and because we're on a Java conferences, it's I guess quite suitable. And my Java code is just a typical thing that we do in Java. We have plenty of midlets in the past. Now after that we have a servlets, and now we have a speechlet.
And the favorite of all time, applets. Right?
Applets, exactly. So
what does this let means is someone controls the lifecycle for you. This is what let stands for.
Yes. So in this case, this is a special type of class, and the lifecycle of speechlet has a bunch of methods that I need to implement. So on session started, on launch, on intent, we're going to be talking about on intent method a lot, and when the session, like conversational session, was ended. So in my application, I implemented this. So even though for demonstrating abilities of JVM as a polyglot platform, I'm implementing my stuff in Groovy, but it successfully runs in, guys, any Groovy guys here?
Yay, Groovy.
Not so excited. Kotlin?
Even less.
Okay.
So far, so good.
So in this case, it just simply compiles into Java bytecode, and the result looks like a zip file. So after that, a zip file can be stored on S3, deployed on S3, or any other like DevOps tools can be used to upload this into AWS. So in my Lambda, this is how it looks like. So there is my Lambda function. I already specified which class starts lifecycle of this speechlet. And after that, I can do pretty much everything in code because it's Java, right? Right?
This is what he did.
Okay, I'm done. Yeah.
Okay.
I'm done.
So, just summarize.
Yeah, I don't have the mic. Let me be like a tiny Google phone. Before we vote for each section, we're gonna have the guys.
Half a minute of summary.
Yeah.
Yeah.
20 seconds, half a minute of summary, and state please what the audience should vote for.
So guys, as you saw, it's very, very easy to start with implementing actions. You don't need to code anything, not speechlet, not controlled lifecycle, not Groovy, not Kotlin, not anything. You can actually provide simple stuff like what she said without going to our backend at all. It saves, the performance of course is better because it's one less step to go, and it's generally simple. I mean, 7 years old can start playing with implementing stuff with Google Home.
So in my case, I want you guys recall your 10, 15 years of experience in Java, and what would be even like simpler than writing the Java apps that someone controls your lifecycle. Come on, like you did this for years in the servlets, midlets, and applets, right? So Java rules even in clouds and in lambdas, like servlet architectures. So That's it. Yeah. So my approach is Java code first.
Yep. So either simplicity and web UI for the 7-year-olds, or the power and flexibility of servlets back to us.
Speechlets, I would ask.
Speechlets. My apologies. So who thinks this round and the round's goal is the simplicity of configuration and the understandability how to get started with that? So who thinks this round should go to Google Home? Excellent. This is just the first step. Not bad. Who thinks that Amazon Alexa should win this round?
Like a tie.
Not a tie.
Like a tie.
It's not even close.
By a small margin, I think Google Home takes this round. So, as somebody said, it doesn't matter by how much you win. Is it a millisecond or a full mile? Winning is winning.
Point is a point.
Let's get started with round 2, and that would be the more complex example and doing.
Yeah, we need the mic back. Okay, so what we're going to show now is more of a conversation for pagination.
The mic's back on.
Okay, Google, start stand-up helper.
Sure, let's get the test version of Stand Up Helper.
Hi humans, Google's here to win. How is Joker going so far?
What is the defects for Viktor?
The top 3 defects for Viktor are WTF 76, WTF 36, WTF 79.
Are there more?
There are 62 more defects for Viktor. Not your best day, Viktor, is it?
Stop. So let's see how it's done. Obviously, there is a backend here because we need to go to Jira and find these 79 defects for a poor Viktor here. And that means that we have another intent, but this intent now does something else because we're not just returning text. So top user defects is the intent that we are working at, and first we ask for top bugs for, in our case, this is a variable of a certain type. We can provide types which will be hints for our system of what to hear. Airport, if I pronounce the airport name not clear enough, it will look for a closest airport name, right? Etc., etc. So username means everything because username can be anything, but I can use first name here. And then it will use some kind of a database of first names from throughout the world to try and guess what I meant. So this is my variable, and those are the synonyms. Those are the sample utterances that Google will multiply using their artificial intelligence. What are the top defects for John? And here I map a username to something that need to be heard. And if nothing is heard, Google will reprompt me until I actually populate it. And it will ask all those questions until it hears a proper username from me. Now, once the input is complete with the beginning of the sentence and all the properties that I need to fill, next there will be fulfillment. And I don't return anything standard because I need to go to the backend and look at it, so I will use a webhook. And the webhook is my fulfillment. Use webhook for slot filling can go to another source for those properties, but that's okay. I just enter them myself. And here is my fulfillment, and it can be any URL. It can use authentication, it can use sample headers, and this is a header, for example, or if we want to make it even simpler, and we spoke about a very simple beginning, if you are a fan of JavaScript, I said simpler and JavaScript in the same sentence, sorry about that, you can actually write your fulfillment in JavaScript right here in API, I love this name, without going anywhere. In our case, we want Java, so we will go to Google Cloud Platform, and I use Google Cloud Platform just because I represent Google Home, but it can be anything, right, any resource. And I'm going to whatever. And in my case, I'm using Groovelet, but it really can be whatever you like. Now, this is the code that is going to be called. I do some setup here. Obviously, we won't go to Jira here. I want to keep code as short as possible, so we will do just some randoms here instead. And then here is my control switch. If the top user defect is started, then go to Jira, find the top 3, and return them. Now, also, I have something here, which is the parameter. And this is the parameter that was passed to me as a property from my request. But also, I do something else. I send a parameter out. And this parameter out will actually go to another intent, which is the follow-up. And that's more user defects. More user defect returns a parameter in. And then we have all those auto-generated, including Pokemon. Are there more? I have no idea why. For the sake of pagination. And here, I can use this parameter, and if the parameter is not there doing something else, for a follow-up intent that, of course, will end up in my code as well. And here is the second part of it. What did I do? Not what I wanted to do. What I wanted to do is, sorry about that, more user defects. And more user defects gets the parameter again. My service is completely stateless. I have to pass the parameter back and forth. And then I go to Jira and ask for more defects. So I guess that will be all. And now back to Viktor. And I think we lost your signal, by the way, buddy.
No, everything's fine. Should be fine. I hope it's fine. Black screen.
We did lose your signal, buddy. Okay, you lost.
It doesn't matter. Yeah, I'll try to reset this, no?
And
Get this? No?
I'll switch to me and then back to you.
No? No signal? Okay, let me talk to my girl. All right, so Alexa, launch stand-up helper. Don't talk to her.
You confuse Alexa. Yeah, we have it. We have it. Don't touch. Leave it that way. Perfect. Thank you.
Okay, so stop talking now. Alexa, launch stand-up helper. You confuse it.
Okay, she's dead. I won.
So, maybe it's Wi-Fi, by the way. Okay.
Nice
Stop.
try.
Stop.
Okay, start showing the code,
Okay.
and you will try. You will give it another try later.
Yep.
It is Wi-Fi.
Wi-Fi. Can you?
Sorry, your Echo Dot lost its connection.
All right. So the Echo Dot. Now, so the same thing available in Alexa console. So I'm building this intent in a modeler. So they have this nice UI that allow you to build intent. And in case you've seen this idea, right? So I ask her what's our current status. So in this case, she has this intent called stand-up status. So basically, if I ask her like what's the stand-up status, are we back online?
No.
No.
The internet is dead.
Oh, internet is dead. Okay.
Guys, get out of the internet, please. Thank you.
We need this. So now, in this case, what happens with when the Alexa service will recognize?
Oh, we're back.
Yeah. So when the Alexa recognizes this one of the utterances that I provided here, she will invoke one of the handlers in my speechlet. So in this particular case, on intent, this is the method that we will spend most of the time, and based on the certain conditions in this huge switch case type of thing, it will execute particular handler. So in this particular case, if we're talking about the stand-up status, based on the utterances, it will recognize this particular intent. It will call the method get update status. So in this case, it will generate a speechlet response, which contains two parts. In this particular case, speechlet response has ability.
You're showing another use case. We're on top defects.
open top defects.
Yep.
No, I think we also talk about status. No.
No.
So okay, all right, cool. We skip it and let me get this. For top defects, actually, it's also very nice in how it works. So in this case, I can parameterize my utterance with the particular parameter, and Alexa service will be able to recognize the part of these utterances with actual variable that I want to use in my code. So in this particular case, it can be in the end of sentence, or it can be in the middle of the sentence, and Alexa service is smart enough to recognize where is it. Now it will call my top user's defects as you saw here, and it will get here. Now with the intent request, this is a part of the request similar to like your servlet request. There's some of the information that also can be passed here. So in this case, I do have this intent that populated with the user information. So in this particular case, I get an S slot. So slot is a variable that you use in your intent, in your returns, to use sample returns to define the variable. And after that, I can use SLF for J, Java logging. That's very nice. And after that, I can call Jira, or I just do some random generation.
I have a question for you.
Please.
So as you remember, in Google, you could ask the user for an input for a missing property until it actually populates it. It will ask, what is the username and other options? By itself, I didn't have to write any code to guarantee that. How it is implemented for Alexa? Yeah,
so in this case, I need to also implement this, or in the console, I need to specify that my particular slot needs to be fulfilled. So in this case, I need to provide this is required, and in this case, there are simple phrases that Alexa will ask you until you provide the right user to request this thing.
So it looks the same, but it actually requires some code on the backend.
Yes, it requires some code on the backend to retrieve this data and use it in somewhere.
Also to check if it's not filled yet.
Oh no, of course, it's in Java we love the checking nulls and all this stuff. So see, I'm a previous developer was kind enough to put the null checks in my code as well. So
these populate request fields will go and execute every time until all the fields are populated.
There is a specific type of object called dialog intent that will be taking place into account here. And after that, I use Java and all my stuff to populate this context.
So if the properties are missing, a request will get to your code. You will programmatically discover that the properties are missing and will send back for another round of questioning until all the properties are populated.
Correct, yes. I have a full control of the life cycle. I can do many things with this.
Now, just wanted to make sure.
Wanted to emphasize.
Are we good? Should we summarize?
If you're done, maybe Viktor can try Alexa.
Okay, let's try and do it.
Alexa, launch stand-up handler. Oh, helper. Okay.
Hola, amigo.
It was Hello Amigos.
Yes, so it was Hello Amigos. Where we are? Hello. I guess internet's still flaky.
Yeah.
Still
It's,
bad.
yeah.
That's okay.
So much travel back and forth to the backend that it brought the whole internet of Devoxx down.
Yes.
Can I ask a similar question since we have a minute? So how would you implement in the Google Home version if you have 5 parameters and you just need any combination of 3 of those?
Yeah. So this is done in this.
Wi-Fi.
Yeah. This is done.
Your Echo Dot lost its connection.
Thank you. It is done in this API UI in which you specify which parameters are mandatory, and that's enough. So looking back on these top user defects, intent that we looked for. So this John is a required parameter, and I mark it as required, and then I provide prompts that Google will reprompt the user until it populates everything that needed. If some of them are not required, I don't have to check this checkbox, and if the user didn't use this parameter in his input, I will just get null in my code. So let's try that for a second.
No, I meant.
The mic's back on.
Okay, Google, start stand-up helper.
Okay, here's the test version of Stand Up Helper.
Hi humans, Google's here to win. How is Joker going so far?
What are the top defects?
For which user?
Oleg.
The top 3 defects for ordered are WTF 99, WTF 85, WTF 98.
Stop. So I don't need 2 mics. So as you saw, it will reprompt to populate the required properties. And my internet works.
Can we?
The mic is
Yeah,
muted.
I think we can. Do you want to show something?
Yeah, in this case, if I want to have this like a conversational type of thing, it does work. Yeah, it works. Now I can have, in this case, when we're talking about top defects, we and after that, it creates a session and puts the user information into the session. So the current user is in session. So next time when I want to use it in, where's my more defects, I can retrieve it from session with the colon the get attribute, and after that continue to do pagination. So in this case, it has a little bit more state on the server side, similar to other things that we do with like servlets, for example, like session, HTTP session that we do during the servlet time.
Excellent. So maybe you can summarize maybe 15 seconds, and the goal for this round would be something a little bit different. So it's not the simplicity, but it's the context, the handling of mandatory and optional parameters, the follow-ups and reprompts, how to ask user for more input.
So with Google, it is as you expect it to be. You have context that you can get out of Google Home to your service and then get in back with the same information or additional information. All the defaults are pre-populated for you, and mandatory parameters will be asked until you populated everything. And you work with this context in your code by pulling properties from it and then putting properties into it and sending it out.
So in my case, it has less magic. We have a full control again with the code, and it has a similar concept that you have over years of experience with the HTTP session and other building the stateful protocols on top of the stateless protocols like HTTP.
Excellent. So let's vote. Who thinks that Amazon Alexa should win this round?
They just haven't heard how she sings. So.
Yeah, I didn't. The demo didn't work. Who thinks Google Home takes it home now? I think it's a second step to the win for Google Home. And let's go into round 3. And you have 6 minutes each, and just surprise us with whatever wow thing you can do.
Okay, so there is one thing that I wanted to show you. It's kind of related to a previous one, but even more improvement on the model that I already showed.
The mic's back on.
Hey Google, open stand-up helper. Now it is the internet.
Internet.
Yeah.
Do you think so?
It might be.
Here's a summary from the website disneyworld.disney.go.com.
Thank you very much.
Walt Disney World
Stop.
Resort Network from a
Okay, Google.
Wi-Fi-enabled device.
Stop. Okay, Google, open stand-up helper.
All right, getting the test version of Stand Up Helper.
This is Google, and I am nothing but a humble AI agent here to serve the developers.
How bad is WTF42?
Oh, no. Defect WTF42 is a catastrophic one. Someone needs to do something.
block it.
Defect WTF42 is a blocker now. Go fix it.
Stop. Okay, so what you heard here is kind of a similar conversation that we showed previously. And by the way, my backup plan, if the internet didn't work, was using a couple of tools that I can type in the request, not going through the speech recognition and everything. So I can do it here. How bad is WTF42? And I will obviously get the same result. I can do it from III, or I can do it from Actions on Google, on which I can actually have the full experience of Google Assistant in the simulator, including the full flow of talk to stand-up helper and going from there. It will show me all the interaction, all the JSON files that come in and go out in order for me to debug it and actually parse this JSON in my code, and that's exactly what I'm doing. So since it did work, I didn't show you that, but going back to API AI, yes. So how bad is WTF42? WTF42 is a defect ID, which is of type any, again, because it's just bunch of characters, and then I put this defect ID into my context, and that's exactly what we did in previous thing. The
mic is muted.
The interesting part here is that when I go to my code and take care of defect severity, look at how I don't need to put anything back to context anymore and stop with this stupid back and forth. I take something from the context and I put it back for the next iteration because I marked this context as living for a lifespan of 2 interactions. So now I can use this context every time I have an interaction coming back to my backend, but I don't need to pass it anymore. And in a follow-up event of severity for decade, which is a block current defect, I can easily use this current defect ID without the need of getting it on my backend, processing it, and putting it back to the outside context. It will survive the number of iterations that I selected here in my intent. In our case is 2. So this is another twist that I wanted to show here.
Okay, so let me try to do the same thing. If it won't work, I can show you some tools. Alexa, launch stand-up helper.
I'm not quite sure how to help you with that.
Okay, this is my Russian
This is
English.
you. This is your accent.
Yep. Alexa, launch stand-up helper.
Live long and prosper, Devoxx people. We are ready to battle.
How bad is WTF28?
Oh no. Defect WTF28 is a catastrophic one. Someone needs to do something.
Please block it.
Defect WTF28 is a blocker now. Go fix it.
Goodbye.
Bye-bye. Not Storovia.
All right, so it also works, but still we'll show you some debugging tool. So on the Amazon console, I can use a voice simulator that will allow you to take some of the text. So for example, in my greetings to you, my great audience, I do have a bunch of sentences that I want to randomly, where is it? Yeah, on launch. So randomly generate. So in this case, you heard something like live long and prosper, Devoxx people. But what about something like this? I hope, can I use the mic real quick? Where's my, I'll use this. And I will show you how you can test the responses.
Hola, amigo. I am ready to serve.
This going to die hello amigo was because of the high pitch.
Yes. So what happens here is that my output uses this structured speech markup language to modify default behavior of the speech of Alexa. So in this case, I'm using higher pitch for this hola, and also I'm providing the special like a phonetic pronunciation of this word, like because it's Spanish, they not pronounce H, and it's hola, amigo. And after that, I can do also a break. In some cases, I can do like an emphasis. So let me.
So you elegantly escaped the debate about the usage of parameters and start showing standard SSML features.
Oleg asked me to show something, and I can show you also like something like this.
Sparta. Oh wait.
In this case, the parameters.
You want to run it again?
Yeah, that's okay. That's fine.
Okay.
So in this case, as you can see here, I can use more emphasis, providing like stronger emphasis will kind of make it sound a little bit longer, and I can provide a more loud sound of it. So you can test this one. Also, you can send a request to actual skill instead of doing this by voice. You can ask something. What status? Something like this. It provides me textual response, and also there is a sound
There
response.
are 42 critical issues. Anything else?
Also, it supports. It shows it.
And this is how the UI will look. As we mentioned, it sends something to the UI as well.
Yeah. So in terms of testing with the device, it's another option that I was thinking to do. You can actually interact with the Alexa if you don't have Alexa because you didn't go in our website with show notes and didn't participate in Ruffle. So you can use your browser to talk to Alexa. You need to register with your developer account with Amazon, and you can talk the things to your computer. Launch stand-up helper.
Ta-dum.
Launch stand-up helper. So internet, browser.
Ready to serve.
Oh, here you go.
So yeah, so here we go. It works nicely, and also supports all the other features. And how much I have? 1 minute?
No.
Yeah,
Yeah?
yeah, we can.
Judge said 1 minute.
Okay.
Do you want to follow up with something?
Yeah. So in the case of like a follow up in my this particular situation with my code, I'm saying with the same tools that I use for my Java development. So I use Gradle. Anyone up for Gradle joke? How many of you Maven people? Gradle people? All right. I like the people who don't make poor life decisions. So that's why we're using Gradle. So with this. Anyway, so I like Gradle.
Your minute is up, by the way.
I'm building stuff. I'm uploading to S3. And another cool thing is that I can see some logs. I can see some SLF 4G, SLF 4G stuff, which is with Java developers love to deal with the multiple logs, configuration with logs, how you can configure this. And this is something that you will see, like all operations. There's info, there's warning. I can see the information about states, so things like
Just
that. Like
service announcement, SSML works in Google Home, and we don't need any special treatment for deployment or logs because we can use any backend and deploy it to any way you like, including Maven, and we love Maven.
Okay, so what do you use for building?
Gradle. It doesn't mean that I don't like Maven. I have tons of Alexas at home, and doesn't mean that Google Home won't one now, and I don't like it.
Yes.
Excellent. So this is probably where we stop showing you the code, and we're gonna show you something else, perhaps. But the round 3 is the final round. So we've seen everything that the guys wanted us to show. Now we will be voting, and this is the whole and general overall voting. We're gonna voting about the programming model, Java speechless versus the generic JSON request to the server, the ease of configuration, the follow-ups and parameter handling, and everything that you would suggest. So if you have a preference, if you are more excited about one of those two, you should vote for that. So who is more excited about Google Home? Wait for it. Who is more excited about Amazon Alexa?
People less excited, but when they will start using, they will remember, their fingers remember Java more than just clicking around the screen.
Nice try, nice try.
Some people are excited for both of those. This is excellent. Now we have 1 minute left, and we have one last thing that...
Yeah. And this one last thing, let me just switch here real quick. As usual, will be an intent for Google Home. Okay, Google. Talk to Stand-Up Helper.
All right, here's the test version of Stand Up Helper.
Hi humans, Google's here to win. How is Joker going so far?
One last thing.
One last thing, don't forget to visit www.jfrog.com/shownotes for the presentation slides, the video, the links and the raffle. You can win an amazing Amazon Echo Dot with my friend Alexa inside.
How cool is that, huh? So, thank you for your time. You were awesome, audience. We have 30 seconds, but we still will be around.
No, the 30 seconds are to say that you need to vote for us because there are some people higher than us.
Oh, of course. If you're using this, you're using Devoxx app. And vote for our talk, vote for Alexa, vote for Google Home.
This is Gamusa on Twitter.
This is JBaruch on Twitter.
Thank you very much.
And this is Alex Shulayev.
Yes, and this is Oleg, and he's more than awesome.
Virtual Jug.